And good morning. Happy Wednesday. All right. So we are going to get started. Where is Alacrity? I've lost it. Oh, there it is. Close down Alacrity. Well, that terminal. Okay. We're going to watch that. Ah, yes, that's right. In the middle of making some tests. Well, the reason I need these tests because I'm creating codecs again. And codecs, magical beasts, like unicorns in a forest. No. Codecs really just help us go from one type to the other. They can do a little bit more than a sync can, actually. So in this case, I think our codecs might actually be a sync or be used by a sync. It's kind of interesting to me. I wonder how they solved the problem that I was having earlier. Oh, I know. I guess I don't know. No, I take that back. Let's say you get some gigantic thing that you need to encode, and so you convert it to a buffer, some sort of byte array, and you're sending that out chunk by chunk over the wire. How does it actually do that efficiently? And I think it has to do with reserving buffer. I see, and the framed writer probably just deals with taking everything out of there and sending it. Okay, well, it's probably the case that the codec is the right place to do our conversion from one to many elements. We don't want to do a watch. We want to do a test, but we don't want to do that there. We want to do that in the TCP server next. TCP server is probably going to go away. TCP server next will take its place. I should have called it like next of kin. And our test is failing. Yay! So, decode. Let's add something to this source just to clean that up a little bit. Maybe we'll do that in a bit. Might need that data. It'll be a little bit harder to parse through, but I think we'll be all right. Let's see here. We can say, oh, look, these are the bytes we're getting. So it is 17 bytes, packet 0, and we should have just 17 or 16 of these. I think the 17 here describes what's following. This should be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 17. All right. Now it's a little bit odd here that this is saying that kind is invalid. It's almost as though I didn't advance past the header, advance far enough. So if we decode the header, and that's what we have. We have a packet codec. Got a state, some metrics, the subject. I like the codecs we had before. But this one is really modeled after the length Link to limited codec. Reserve N. Sure. When we decode the head, we check to see, do we have enough? We wrap in a cursor so we can get a uint out of it. Usize. That's returned as N. But we're not doing anything with that, are we? We could say a U16, not a 61, U16 as usize. Tracing N, we're going to reserve N number of bytes and it'll do its thing here. But we want that many bytes, and then later it'll come back saying, hey, not that many bytes, and we should then be looking at decoding data. What's important, I think, is that we didn't actually advance the read position here. It's good. Okay. Now when we go to decode data, we check if our source length big enough, otherwise we say, hey, we're not ready yet. We keep returning okay, none until it's done. If we have enough, we split it the length. Split it to n. I wonder if that should be like n plus 2. This heavily revert mod, no, not that one. Okay, util. Oh, here's our decoder. The other one. It's not there. Thought I had another buffer open for a length delimited codec. So in this state, we have n, we have the size of the header, code data n. Decoding. Let's add some more tracing there. We'll say n and decoding data. Hey Carter, good morning. Figured out what the packet issue was yesterday, and that it wasn't, the client wasn't reading correctly. Set up some unit tests on the client and figured out that I wasn't forming the packets correctly on the server when I was sending 2 at once. So basically, here we're redoing the code on the server so that we can send 2 packets at once. Also, it has unit tests now. So that'll be good. All right, that's encode. Oh, that's so weird. Am I getting... No way. I had a tab open to Musein's channel and could hear my voice echoing in the distance. volume was really low. He's hosting my channel. That's very kind of him. All right, so when we go to decode, we'll say we're decoding data, toss an n out there. We'll call self decode data. We'll match data, and we'll go back into the head state. We'll kind of toggle back and forth between the two. We reserve 2 packets, because we need 2 for the length. Make sure the buffer has enough space. Okay. Try to form the packet from bytes. And try to do this after actually finish reserving the data and all that. Want to make sure everything's fine there, that we've completely kind of moved the cursor forward on that read head before we end up doing that. Oh, there's try from. That's not what we want. Actually, they have some neat documentation on that. That's cool. All right, in this case, or the packet type is 0. That's actually a special packet. We actually have to consume that here instead of down here. It's never passed through as a packet. All right. Let's see. I am finding that very difficult to parse. We're going to go ahead and add source to that. And if we need it somewhere, we will log that explicitly. There we go, like the head. Decode head. So we start, we're in state head. We have 2 different states, head and data. So first, we have these packets. Great. TCP server. So it says that it's reserving 17 bytes, which is correct. It should be reserving 17 bytes as we use 2 bytes here. Then we go straight into decoding data. N is 17, fine. Because it didn't advance past the header, when it started to decode it, just saw that, oh, this is type 0, packet 17. I see. advance 2. I'm a little surprised. Why does decode data not do that? Split to n. Yeah, I think we want to do a source advance there. Oh my goodness, to save a file, I type C followed by a period. It's very easy on my Dvorak keyboard in Vim to just hit C dot. But it does make things like typing source very troublesome. That should advance us past the header. Invalid type 1. Valid type. So that means it advanced it past these two. Wait a second. What do we pass? Decode data. As source. A reference to the buffer. Fine. What does split 2 do on that? Let's see if we can pull up the docs here. Splits the buffer into 2 at the given index. Afterward, self contains elements at length. I see an add is what we passed in. The returned bytes mute contains elements 0 to at. So we're splitting up to 17. I see. So we do have to do that later. Alright, decode data. Move past the packet length there. Not mutable. Wait, what did it say here? Invalid type integer 1. Expected bytes. And if we don't do that, yeah, mutable integer 17. That's 17 right there. I think it's referring to this one and not the other ones. Maybe we should change those in our test. 2, 3. Oh, come on, why is this so hard to type? 5, 6, 7. 10. Oh, I guess. Silly me. Okay, that works. I lost the code. Decode data. I don't want to see what this value is here. Let's take that out. Going to n. Yes, this is incorrect. This should be n, well, plus 2. We didn't get the whole packet in there. Wait. Does that mean that all of the n is off by 2? Decode data. Where does it get n? N is from here. Decode head. We use n further down here? I think so. Okay, so let's do that there. Alright, so there we got the entire split. That's good. So kind 0, still, yeah, because valid type integer 17 is still at the beginning of this. We still need the advance here. We had 2 issues. It says it's kind 0, converting kind. Valid type integer 1, expected bytes. From. That's pretty good. Okay, so let's go look at the try from for the packet. Packet, here's the try from. Skipping anything, maybe bytes. Question mark. Bytes. Expected value. Found crate. Oh, that should be data. There we go. Didn't get that set up right, did I? That should have been data. Anyhow, trying to convert packets. 0, and then the whole thing. Oh, what is this T doing there? Oh, that's 9 and 10. Funny. 13/R. That's interesting how they're... That's like that. Huh. Okay, but it does look like it starts out correct. We're supposed to take that off of there. That should be done here. Then incoming packet kind. We're able to convert it there. Really, all we're supposed to be doing is some kind. Try from kind 0. I guess it's already doing it here. Oh, if it's kind 0, I don't really handle kind 0 in here. We shouldn't be doing that. That shouldn't be done there. That should be done down here. I see, but hmm. All right. Now in this case, let's just inspect the first element in the array. So it's going to be what? Data. Can we just use the syntax? If that's the case, technically we will advance past it. Advance 1 byte. Valid type, integer 1. So here we have a decode data. Splitting to this. It's fine. Unwrap. Okay, so this is actually the test here. What's our test actually expecting? Oh, it doesn't know. It doesn't know. Interesting, it got an error back. Invalid type, integer 1 expected bytes. That means that it bailed. Bring the decode of Saturday from slice. Question mark data. From slice. Type ID. Type ID should just be a UUID. Yeah, that's 16. If we do something like, let's go look at any serialization that, we've got all sorts of tests with serializing UUIDs. I'm missing one value, aren't I? The thing that actually describes the type. All right, where would that be? So this is going to be in messages. Which one of these? ID callback, maybe. Ah, byte array marker 16. That's what was missing. Where do we get byte array marker? From game types test prelude. It's type 0. So we need byte array marker, an array of 16 elements. That means that it becomes one more. Oh, and for test code, we have to include this as well. Yay, okay, now we got a none value back. We got our parsing correct. Yeah. Now we could do 2 of those in a row. We could do something else. This is our encode test. Is that really encoding or is that decoding? I'll decode. Fine. Oops. Decode. Now we should assert this. Assert value.is none. Oh, it's a result of an option. Okay, so in that case, we will unwrap it. Result, but none. That's only testing half of it. The other portion of it, we should really just tack on one more packet in here. See, what about the ID callback? We already have this element here. We could toss that on there. Now for that, we will also need the header information. So what is the, okay, so in here we need type, well, the length. Type. What is our type on these? Oh, look, it should have 19. Callback success. Oh, that's for outgoing packets. And for incoming, actually, ID callback is really just an outgoing one. Drat. It's going to be so convenient just to use that. All right. Get actors. That has actually nothing in it. The type callback. It's transparent. Yeah. Okay, let's try that. We'll create a get actors for our decode. So we still need the size of this. We'll put 2 bytes for the size for now. They're both 0. Okay. And we need the type, which is a 0, and then I'm just making them placeholders at the moment, and then the actual callback ID. And the other example we said was OX07, which we could continue to do. Truly, that's just 7 in decimal. Okay, so this is going to be a size of 4. No, not a size of 4. We're missing stuff. So are we missing stuff? I don't think we're missing stuff because we just treat this as transparent. So let's try that. We'll say it's a size of 2. All right, and what is the packet type for get actors? Back to messages here. Get actors, 26. And the callback ID. All right, that shouldn't have broken our test because we just added more data to the buffer. But now we should be able to do this again, which will fail because it shouldn't be a none. Gotta get that to fail. Good. Same as some. We'll just unwrap it again. That's our new value. And this should be dot. Let's just debug that. Oh, goody. Where did this come from? Oh, this is the UUID we passed in first. Yeah, you can see all the hex bits there. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Wow, all the way to 16. All right, so we can validate that the kind is 26 and the data is 7. If we really cared, we could actually validate that too. Let's validate all 3 elements. So first, let's check the kind. Assert equals value dot kind. I like to put the expected first. You know what? I thought that we also had in game types assert vectors equal. There it is. That's just a function. Okay. We expect data to be that and value dot data. We will also assert that the UUID is the same. It's interesting because it doesn't need to be the same. It just need to be as something at this point. What am I trying to test? I think just that it's something. Value dot. Yep, and validate that as something. Put that up there. Call to vector on that. Awesome. Okay. That's the encode side of things. What about, or the decode side of things? What are we going to do for the other side? And we could do exactly the opposite of this. Just construct this packet and expect this information out. Maybe the simplest thing. Another test. Tokyo. Async. Oh, wait. Goodness, I did that wrong. The name comes after the keyword FN. Let's create one of those packets. Actors is going to be a get actors. There isn't a new on that, is there? Yeah. I think this is just a ID callback. Callback 7. There we go. And we need encoder. I should still work without from. Toss one of those down here. We're using the dev null metrics. Packet stats. Fine. Codec. Just call it something else. We'll call it writer. Encode. Get actors. And that should return a result. Into the buffer. Oh, I see. I have to give it a buffer. And this is a mutable borrow. Let's just get actor. Fine. Get actors. Expected packet. Okay, what? Actually, I think. Oh, I don't have a convert for that into a packet. Technically, that's correct. I actually don't send that packet out. That's an incoming only packet. All right, let's look and find a different packet we can use. And there's our incoming packets. Here's our outgoing packets. 0 special, that needs to go away. Go ahead and get rid of that. Oh, you know what? We do have outgoing packet kind get actors here. Oh. Still 26 as well. Oh, that's convenient. Oops, let's go, not this buffer. Get actors. We have a to and from bytes, but we don't have one for packet. Simple. Something packet for whatever. Let's look at the position one. From position for packet. Do I do that the other way at all? Doesn't look like it. Okay. Set this up for get actors. Whoever, get actors. Here, let's do the multi-vim there. There we go. But it's mutable, needs to be imported. No quick fix, no. Oh. Packet's not in the scope. Ah, there's a quick fix for that one. Let's go to position. Where's... Clean that up. Outgoing packet kind. All right, now that's just wrong there. That's fine. Using some multi-vim magic. That just failed gloriously. It was anticlimactic, really. Hit tab, CW, call that get actors. There we go. Now it doesn't have an entity ID. Oh. Does get actors have a subject? No, it doesn't. Like, maybe a none. Or rather, does it change the subject? It doesn't. All right, but this, I don't know if that's correct. So if we look at packet or position, there we go. Here we actually assert that the length is 3, etc. Let's go ahead and add something like that to the other one just to make sure. Oh, and you know what? We're actually converting this one to a packet, etc. Go ahead and enhance the other test to mimic that. Here we'll have a get actors. Yep. I wonder what our data is going to be. It's not really a list marker. It's just that one element. Be fine. Now our actual is get actors.into. Set conversion on it. Oh, that was the expected. That's because these two tests are opposite. This one's a deserialize and the other one's a serialize. I cannot treat them the same. There we go. Now we'll serialize that, convert that into a packet there. Our vector, I think it's just going to be OXO7 because of the callback. Oh, no, no, no. Can't be, can it? What about, I guess if we're just serializing it, it doesn't have the extra stuff on the packet. It's not like we're validating packet kind and stuff like that. Just that it can go through packet. Okay, length here then is going to be 1. And we'll toss that in there too. All right. Let's run the test here in cargo messages. Well, just in messages. Outgoing packet kind. Yes, ID is gone now. That's true. So messages lib 145. Did I miss one? Oh, I did. That's encouraging that it was just that one element. Function's never used. Get actors. 64, because it's not marked as a test. Again. Good. All right, now let's go back to the codec that we're working on. Now we have that. I'm going to encode this into the buffer. Oh, it's not declared as mutable. /qf. Oh, quick fix. Thank you. Thank you. That worked. TCP server next. we're not using the result of that. We'll just unwrap it. If we get an error, it should fail the test. Now in this case, we need to be able to compare those vectors. Oh. Insert vector is equal expected than the actual. So in this case, I don't know what I'm expecting at the moment. Let expected equal to just a vector. Yay. Okay. Expected then actual is going to be buffer dot to vec. There. Yes, length is not correct. Ooh, the right has a length of 1. What if I did 0? Why did that fail? Oh, here. Now let's just do the encode test. Let's change this. Filter on just the encode test. There we go. Much easier. I think this is just going to be the number 7. A little surprised. I thought it would be more than that. Oh, I see. 0, 1. Well, that should be different than that. So this is going to be the length of the buffer, the type of the buffer, which is 26, and then the value of the buffer, which is 7. Oh, I got it right? Lies. Let's change that to 27. Does anybody else ever do that? Like, oh, I got it right the first time. You're like, no, that's not possible. And if we add an extra, that should still fail. Oh, that index 4. Okay, good. Yeah, that's the length, the type, and the value. And see. Now, if we happen to give that a subject, if we primed that with a subject. Yeah, you do that all the time. It's like, no, I don't believe you. Yeah. All right. That's not bad at all. The thing that we're missing, though, is the send of the subject. Because here we're converting it into a packet. I think I want to adjust that there. Make that into a packet, and then we will say packet.subject replace. And I'm just going to give it the default UUID. Which is just a UUID with zeros in it. But it should mean that we're able to get ID packet out first, and then we get out the next one. What do you mean? TCP server next doesn't know about that? Can I just do default? Why does it need type annotations when it knows what that is? It knows that it's a packet. It knows that the subject of a packet is an option. That's not mutable, okay. Guess it didn't know that it was a packet. Ah, good. Yes, now we're actually getting the 17. Okay. And what is this going to be? This is actually going to look like this up here, except it's not going to increment. Complete to 0. Toss that up there. Let's multivim this. Oh, almost. You almost got it, multivim. Oh, I hit the wrong key. All right, let's try that again. Oh, that's right. You have to hit tab first. But the cursor's already blue. I wonder why that's the case. Huh. Could have changed them all by hand. There we go. Zeros. Okay, now get actors. 26. Let's decorate that there. It's, interesting. Build at index 1. Left says 18, the right says 17. This isn't 17. Oh, is our encoder off? Ooh, I'm glad we're doing this test. Why would the left say 23? Build at index 1. 23, 17. All right, let's just change this to hex. It should just be 18. And if we go back into messages, look at how that person works. Oh, it's in game types. Game types, almost game types, lib, build at index such and such. So that is a correct error message. Just verifying. That's verifying. So we'll save that, run it again. I do find it interesting that it's off by 1. Why would it be 17 instead of 18? What is it getting rid of? Is it the byte marker? Guess we'll find out. Oh, does the length not include the type? Okay. So this length here doesn't actually include... I don't know if that's correct or not. We could always run it against the client and see, expecting that the client would blow up. I think we're expecting parity here. And this, which is 18, oops, no, 18. Because this here describes how many bytes follow. It should be the same thing here. This should describe how many bytes are going to follow. And this here is 18. That is okay. So let's figure out where that is in our code, because this here describes how much data follows, and this should be 18. That's 18. Great. This here describes how much follows, which is 1. It should be 2. That should be 2. So we can see there's 2 bytes there. Okay. We've gotten off by 1. Our encoder. Encode. So this is calculating how much buffer we need to reserve. Should be the length of the header plus say type here. These should really be in the same order. I know an off by 1 error. Rust doesn't protect you from what I call the nut behind the wheel errors. Why do I have 17 and 16 here for this? That doesn't even make sense. Length. The length of the other packet. All right, that. It's a late night change there. Reserve capacity in the destination buffer. Okay. So the way that this code here works is that we say we want to encode something. We check to see that, okay, the length isn't more than what a 2-byte number can hold. Then we check to see, this is an outgoing thing. Should we update our internal subject pointer? Okay. If we should update that, then we also need to include new packet type 0, before the actual data. And here we're trying to just reserve as much data as we need in the outgoing buffer for both of these things. Now the value there is that packet ID 0 needs, let's see, so this is wrong, isn't it? Because it's not 17, it's really 18. I think that's part of why this is all wrong. Yeah, because we're missing the CBOR tag on this. That's it. So packet plus UID to for the length. How do you represent this? Header to find 1 tag 1 and then data 16. And if we add that up, that's 16, 17, 20. U16. All right, and the way that those packets look, we have the 2-byte length. Okay, in this case, it's not that. It's going to be 18, because we do not include the 2 bytes of header in the length. Just when we're reserving length, do we do that? Now we're actually missing one element here. Okay, and this is the EUID tag. I can find that. If we go into, I guess those tests we were just looking at. Byte array marker. What is our byte array marker? Oh, 40 plus the length. OX40 plus length. And that length there is going to be what? 16. OX10, so this should be, oops, that should be a 5. It's just that easy. Left 0, right 80. So it doesn't like our tag here? At index 2. Oh, we've made it past index 1. That's a wonderful thing. Battery marker 16. Is the binary marker actually 2 elements? No, it's a U8. Oh, here, this one. It's saying index 2. Is this 0? This is 1, and this is 2? This 1, that's 2. Is it 0 based, 1 based? Let's give it something that we don't have in there. Let's give it 9. Is it that one? 9, yes. So it's expecting this to be up one more. We're missing the packet kind. Okay. Oh, I have that afterwards. There we go. I had those flipped. Goody. Okay, now we're at 4. One, two, three, 4. Oh, wrong one. Yeah, so we have packet ID that, tag type, just that. Why would it think that that's correct? Trying to do that down here. All right, I'm going to change these. 1, 2, 3, 4, 5. Is it any one of those? 1. This is our header length. Be 20 or 18. Sorry, this should be 18. That's good. So when I do that, I'm actually looking at this little number down here. It shows me how many lines are selected. So we have our binary marker. Okay, so this is our kind. Let's annotate this. Kind 0. Tag. That should be fine. And then we just have the data for it. Why does it think it's supposed to be 80 at that position? I mean, it already did 80 here. Why is it doing it twice? Oh, did I include it twice up there? Where's our encoder? Looks like it's only there once. Use 16, U8, U8. Serialize that. And oh, it's because the writer adds the tag. That's why. We don't have to put that there because here the CBOR will add the OX50 for us. That's why it's in there twice. Yes. Okay, now we're down to the 0 and 1s. Oh, good aim. Okay, now at 21, 0 to 26. Build at index 21. See if we push it there, that's 0. This is 1. Index 21. And 1. Honestly, I don't know which. I must be talking about this one. Now we had 18 bytes here, 18 byte header. Here we have 2 bytes byte header. Let's make sure this is correct. Encoder. Let's set a marker A here. Okay, and change subject if needed. There's that. Packet length. What does it think it should be? Packet length. The data length? What's missing from that? That needs to be... That's off by 1. Because it doesn't include the kind. Oops, did I go too far down? Oh, no, here we go. Here we have the kind. And then we extend it from the slice. Okay. And there. I am so glad we did that test. That is so much better. Okay, let's actually run the game server. So last night I did some unit tests. While that's baking, I can show the unit tests I did. Now in here, we have tests. We have the decode tests. So I ended up testing that it could decode the correct thing twice. See that this has... this is interesting. I wonder why in this case I have 5 then 0, and then the other one I'm doing 0 then 5. That doesn't seem like it's a good thing. Length. Did I get this backwards here? Something's off with that. Those feel like they should be swapped. Unless I'm reading them. Available bytes, get U16. Wonder if I got my encoding of the header backwards. All right, well, that's something else that we can test. That should be pretty marvelous failure all on its own. We're gonna go ahead and play the project. No, actually, did it finish compiling? Let's check on that. It did. Okay. There we go. Both together. Log in. Okay, yeah, so something's working. That's good. Now, if we log in as, let's see, who is our willing participant of the day? We'll create a new captain. Captain Crazy Cynical. All right, there it is. That worked. Great. Oh, we had a breakpoint in the Godot side of things. We were not getting this packet before. Okay, let's bring that back. On island, yep. Oh, look at that. Oh, you can't see it. It is fuchsia. All right. Oh, was I still? I was at a breakpoint or something. Okay, let's try that again. Run the game again. I want to see what kind of island they get. Oh, a server panic. No. Player should not yet have a location. That's right. Okay. That's because I didn't get LinkedIn working yet. That is like next on my list. Let's restart there. Connection lost. Log in again. Hey. All right, now give me a moment to parse your handle here. I kind of want to say Sansenlight. It could be Lichet, something like that. Sanson, good morning. How are you doing? Let's see. See if this still works. Right. Oh, and it's hitting this assert in the client. Output. Did that thing go false again? It did. Ah, but the stream peer actually changed. Okay, so I have some bug in the client that's actually changing the stream peer. It is so close to working. Let's see, will it just keep going? No, we get fuchsia. Yeah, we got fuchsia again. Oh, it's a Norwegian word. Now, do you mean whatever in the literal sense? I'm kidding. I'm kidding. Goodness, I wonder how you'd say that in Norwegian. They have phonograms on it. I just can't do. It's like trying to say Dvorak correctly. It's Dvorak or something like it. It's got this great like that J sound in the middle is just so hard for English speakers. And okay, so why in the world then would our socket be changing? Okay, let's dive into that for a moment. Who has access to this? Well, okay, there's one. It has access to it itself. This thing's getting recreated. Ooh, that could be happening. We must be doing that. Yeah, this thing must be getting recreated. Let's add a log line in here. Print debug. No. Okay, let's see if we see them more than once. Should probably get rid of some of my other print debugs. And that one's not very useful. Look for some of our others that are currently. Okay. Comment some more of these out. Good, good. Uh-oh. That one's fine. We'll leave that one in. All right, it is connected to host. Fine. That one we'll leave in. Oh my goodness. All right, and we only got one no. Oh wow. This has been like 3 months since we've actually seen this scene. Can't move around. Actually, that thing just asserted false on me. What is the error info? Error 1. That's not helpful. Oh. And 0 bytes were sent. Okay. Hmm. I wonder why. Error 0 is completely generic. It means that something bad happened or something happened. It's not all that helpful. Now what I wanted to see was when that happened, are we still connected to the host? And this is still true. And in this case, these numbers didn't actually change. That's surprising to me. Like why? And we didn't see our no. We only saw that once in this case. Huh. Try again. Fuzzy Pants has a different kind of connection. I can't actually move around yet. That's fine. But if I click enough, the assertion fails. This seems like it changed when I went to version 03. Oh, you know what? It also said that it couldn't parse the packet. I wonder if the game server is just dropping it. Because clicking might actually get rid of the connection. Let's go back here. Now we're going to add a lot more logging. We're going to say stream multiplexer. Let's trace. Yeah, that's going to be a lot more. But it should show us if it decides to drop the client. I actually want to see both at the same time. I'll click login. Go. Okay. It's fine. Still connected. Ah, yes. Client is having its own issues. We click. Interesting. Let me click again. Not an auth packet, actor ready. That's strange. Why would it say it's not a game master, not an auth packet? Find, actor ready. Ah. Yes, we just don't know what kind it is, and it's technically not dropping them at that point. Where does that function get called, though? Here, and then we just trace it out. If let error. Yeah. Then it goes back and it tries to read the next one. That's fine. Shouldn't cause the client to panic or anything. Thing read. Shutting down set. Okay, so it did actually shut that person down, but I don't know why. Let's see, did we send it a... Oh, did that error bubble all the way back? Shutting down stream sender. I wonder why. Huh. Interesting. Alright, well, so that's the next direction I'm going in. Try to figure that out. It's nice having the game client working again. I'm gonna pour some tea. That cool off before we jump into that. Actually, I'm pretty jazzed about the whole connection working. You can see that the tick is going there in the background very, very slowly. Yeah, I have it on like a 20 second tick. There we go. Some tea poured. The thermos away. It appears as though when the client is having that one issue, it's because it was stopped on purpose. Now, why? Why would that happen? We have that, oh, here. I was trying to highlight that line using Vem keys. Tmux didn't do it. Here, we said we couldn't read that packet. Error reading GM stream packet. And does that bubble out? Well, that's where we were there. I don't think we're purposefully dropping them at that point. I think the only place that we currently send the drop command is here. That I do. Is shutdown. Outgoing packet shutdown. We should be able to just do a quick search in the code base. See where that happens. Oh, more than I thought. Let's stop the game server for a moment. So this is in process function. Incoming. Oh, we do. If we get an incoming packet that we can't process, we drop them. Huh. That'll teach you. Don't send packets that we don't recognize. Okay, well, in that case, what was the packet? Let's implement it. Seems fairly straightforward. Packet kind 2. Let's go to messages. Incoming channels. No. Where's the next 2? Incoming packet. We have actor info. We didn't move that over yet. Probably destination. Let's go look at the previous codec. Yes, that is destination. Let's see, which one of these did we already do? We did actor info already. We did create account. We did login. We did get actors. Those are done. Create actor, load actor. Yes. Zone info. I think we just finished. Take that one out. This is getting smaller. Oh, 0. We already implemented as well. Goody. Okay, so 2. That's a. We call it destination, but it looks like it's just a position packet. We wrap that in destination. Okay. Line 2. So when the client clicks, when the player clicks somewhere, we need to know where they're clicking, etc. And oh, that's better. The destination gets sent to the server. It figures out, can you path to that point in the world? Currently the world is all open, so you can path anywhere. And it calculates a path. Due to there not being any collision, it's currently a straight line. Then it will generate a path and send it to the client. And path information should work well enough for when we do have collision in the world. So that's already worked out. We're just putting everything back together. We had taken the game server apart in order to change basically how the back pressure was working. I think this is all working out really, really well. So now that we have that, I actually need to be able to say, what was it, a position packet? Here. Okay, good, we have that for packet. We do not have it for bytes. Let's do a quick search, impl bytes. Or actor info. It's basically the same set of stuff here. So that's for position. That's right. Now we need. We'll just take this whole thing and clean it up at the end. Oh, this should be crate. Message error. Oh, duplicated, fine. Okay, standard stuff goes at the bottom. Byte stuff goes together. Game types, you go together as well. YSIW, oops, YSIW, right curly bracket. There we go. coordinate. That's better. Okay, now we have position packet that should work. Except we don't have anything that handles that yet. We have to hook that up. TCP server connection. And we still have a handful of these. Wonder which island is. Didn't I already do that one? Handle message position. Oh, that's different. TCP server. Handle message. That already got moved over to Game Master? Okay. It's... Well, it's not wired up yet. Test this out. It should be a known packet now, so hopefully it doesn't drop us. That's not really guaranteed, but being hopeful. It's good. Now let's click somewhere. Oh, oh, oh. There we go. Packet could not be handled by Game Master. That's fine. Yes, but now it's not dropping us. I can click over and over and over again, and we're not dropped. Good. Oh dear, that tea is hot. Wow. Actually, it's really nice that it, even though it couldn't handle it, it still parsed it just fine. Good, okay. Let's get this other element wired up. So in Game Master, in its lib section, we have process. And we call self.blah blah blah. We look at actor info. This is in Game Master source actor info. Okay. Load actor, same thing. We need destination and self. No, I liked the old naming convention, like handle destination. I actually admit that I really like that. Maybe I should go back to it. Let's put that here. Self.destination doesn't exist yet. It's fine. These aren't quite messages anymore. These are packets. Alright, I'll rename it later. Mod. Destination doesn't exist. It's fine. Okay. Now what was the other file that we had? It was Game Master source handle message destination get move. that to just destination. Destination exists. Are you kidding? Oh, well that's kind of cheating. That's like... not even a real packet. Come on. I don't even think we need to do that anymore. Let's get rid of that one. I'll move that. Good. Game master destination. Cool. A little better. This one's actually super simple. Yeah, we're just adding it to the ECS. Okay. Yeah, there's some things in here that need to be updated. Security, it's not quite right. Timed message destination. It used to be sent to it. That's not happening anymore. Actually, handle message destination. Handle incoming destination. That used to be the file. Yeah, that's gone. Alright. Well, let's clean this up. It looks like the only thing it was really doing was recording the time or how long it took to get the destination over here. What used to happen is this would get parsed, or rather the destination would get parsed, and then it would basically get in-queued to be sent to the game master. And due to the way that the back pressure works now, you don't really need any of that. So like this GM handle destination. No, that's really not needed. Does that even exist? GM. Really? Metrics. Events. Game master. Handle destination. Okay. Yeah, I really don't know what we would actually do with this anymore. Looks like we really just used to time how long it took to do these things. I'll have to come back around to that. That's not useful. Let's take inspiration from load actor or actor info. So you're going to need all this. Go back to the destination. Start with that. Destination, we have an incoming message packet. That's fine. We will decode it as a position. I believe. We also have the connection ID. We will do some validation. we need to look at load actor for the security stuff. Okay, we'll do that. Go back to destination. Be sure the connection controls the entity. Now, does position say who? It does. It says entity ID. And technically it's not only outgoing. Yeah, we serialize and deserialize it. Oh, that's right. Okay. And the subject of this gets added. That's coming through. Okay. Position. It's not quite. It's not going to be on position that we need that, is it? Yeah, I think that was correct. That's outgoing. When we want to send something outgoing, we actually need that. This is weird in that when it comes back in, the subject of that isn't actually on this packet. Almost like I want a destination a little bit different. Either that or when it gets decoded, it has to look at that itself. I think what we used to do, like forever ago, is when it gets decoded, it actually gets the entity ID stamped on it from whatever the current subject of the stream is. Let me take the game thing down. That's not even the case anymore. I mean, even the packet is outgoing. Maybe we should just get rid of position here. Say that's the responsibility of the packet of a subject of this. I guess this is kind of the rub here, is that we need to know what the entity ID is and how do we actually pass it into this without needing more information. Ooh, tricky. Yeah, I'm guessing we just do none here and let whoever needs to actually set the subject afterwards. That should be obvious because entity ID is gone now. All right. we go. Now send and receive have parity. As control is now on, it's on message. Message dot value dot subject. Okay. And we're going to get rid of these elements there. And then looks like, well, if we can get rid of the compiler errors. We already have position, so we can get rid of that. Self.data.read ECS, add destination. Why is it still grumpy? Pry from that. Expected result, found unit. Oh, it's whining because the return type, the whole function. There we go. Okay, that's unimplemented. Fine. We get that. That looks good. Connection state. Ensure that they have this. Sure, that's uncommented there. Good. Message value subject. Interesting. Should probably return an error for that. Entity ID is going to be message value subject. Oh, is that actually in now? Expect none. Let's go to the browser on this one. So in this case, we want option. We can say expect. That'll return that for us. We want to be able to map this to a type, like else. It's okay or else, and that should give us the error type with the result, and then we can do question mark operator on that. Okay or else. There we go. And this here will be what? Game master error. It's kind of like a stream subject is needed. And we could just do text. Not a game master packet. Nope. Connection state. Yes, so we do that. Toss a question mark on there because that's a result type. Should bounce that error back out. Oh, what is a connection state? Oh, connection state takes a connection state error. Drat. Stream subject. This will just be the connection ID. I think it's just game types. No, connection ID is a use size. Comma there. There we go. Entity ID. Good. Oh my goodness, this has been forever since I've even gotten this far in the code. This is awesome. We get a read lock on that because self.data is protected by a read-write lock. We have an ECS, which isn't there anymore. No field ECS on type future, read dot await. Self.data. Well, how am I doing this elsewhere? Like in load actor, stuff like that. Let's do game mouse for load actor. Yeah, self data write await. We have data. Oh, that's right. Data and ECS are separate now. Okay, let's go back. Go look at Game Master. We have data and we have ECS. Read-write locks on both of them. Actually, what kind of read-write lock is that? The Tokyo one. Okay. ECS, read, await, and destination. Might not exist. Ah, we need our entity ID. Good, we already have that. Position X and Y. What does that return? Nothing. Interesting. That seems bogus. What sort of error do we have? Game state error. This should be games. Let's see. ERR. Game state error. Invalid entity. That looks like it should be ID. All right, and in this case, we'll just return OK. Not seeing it. Oh, one more parenthesis. There we go. Which means that we should just be able to return that with a map error on it. Map error into. Goody. Okay. Bell. Now let's do a cargo watch. Entity ID on actor info. What? Oh, position doesn't have that. Game master actor info. I didn't just do this in the wrong place, did I? Oh, no. This is because it said that the packet was responsible for this now. Okay. Well, that happened really early. I was expecting that to be more of a delayed issue. I'll into on that right away. Now we have message of type packet, and we can say that we could just call it a packet. Position packet, something like that. Packet subject, replace with that. Come on, $sign, end of the line. Thank you. Two were supplied. Did I give two? My mistake. That's just now packet. Quick fix that. Good. Cargo build and dev run. Here we go. Game master destination. While that's doing that. Oh, no such field. Oh, that's on the test code. You are right. Technically not needed. All right, one more quick fix. Done. Now, let's see what this does. Start up the game. Log in. Code with game. There we go. It just dawned on me that I might not have been showing that in that window for all morning. Yeah, we're gonna log in. Captain Fuzzy Lips. There's a bug here. I have to actually click the game for the world to show up. Okay, so there's something wrong there. Now we clicked, but we have to wait for the tick. Well, where's our tick? The tick normally goes quite a bit faster, so let's see. Let's click again. I'm gonna click in his puddle. Error could not be handled. What? Not a Game Master packet. Actor ready. Why are we sending actor ready packets? Oh, did the server not follow the protocol? Like maybe I was supposed to respond a certain thing to actor ready. Yeah, click, 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 click. We can click a bunch. That's good. And here we are sending packet 2. And packet 2 should be a position packet as a subject. Okay. Has some data, which a 2-element array with X and a Y, saying where we want to go in the world. All right. All right, let's figure out why it's not working. Encode should be doing some more stuff. So we're not actually sending out. Are the systems even wired up to ECS currently? ECS Game Master. I think that's in game state. State lib. Okay, we have those there. Pick. Destination system. So it should be processing destinations. Unless, of course, the destination never made it. Add destination. So let's trace that. Entity IDs. It's wrong macro. X, Y, and ID. So those are all in the arguments of above. Adding destination, that's fine. Field value is not satisfied for what? Probably for the previous thing. All right, and then we also have trace error for that. Look function slash. No, don't. Okay. References? No references found for that. It's in a different crate. That's fine. Now, if we go to Game Master Destination, could this be failing anywhere else? So there's a lot of places that it could fail. Okay. Build it again and go. And restart the client. There we go. All right, we'll give it a moment. Very good. And started. Have our connection. Choose our captain. Feels like there's already a packet that server didn't process. That's what I'm thinking. I need to get Wireshark to actually inspect that. Okay, now I clicked find 3. What is, okay, I don't remember what packet 3 is. Packet 30 couldn't be handled by Game Master. Oh, add destination. So it did do it. That's good. Oh, that's fantastic. All right, so let's go look at system destination. So in here, this is part of the ECS system. Let's take down the game bit there. See the whole thing. And with, I'm using specs, SPECS. It's in cargo or in crates.io. Now in this case, when we do a run, we're actually looking for all of those entities up above, right? Entities, IDs, etc., etc. Destinations is the list of destinations that need to be processed, right? Or however many clients that have just sent us a packet, we will process them all at once. It's kind of interesting. I wonder if there's an opportunity to actually not do that on some sort of tick, but to just always just do it. Interesting thought. I wonder what the trade-offs are. I'll have to consider that. Right. But in this case, we check to see if the destination is different from your current point in space. If it is, we continue on. We just calculate a straight line and create a new path. Okay. Say this is now processed. And then we remove the processed entities from this. As you can see, we're removing them from the destinations, which is fine, and that's good. It also means that you could send, 5 or 10 destinations and only your last one wins if you send them within the same period of the tick, which currently is at 20 seconds. Usually it's at about 30 frames a second. It's a very interesting opportunity here. All right, try not to get distracted with that. So we should have a new path, and that should then go into what? How do we tell the client they have a new path? New paths. I'm not sending this out here. Back to game state. Where's the bottom? Okay. It doesn't look like we're ever sending these things out. Let's look at Trailblaze. I mean, this one is just for update the entity's location based on the current path. That's it's not going to be in there. Oops, too far in. It must be in here. Like we should be sending out new path to the room. Paths.insert. All right, where did that go? A trigger zone. Oh, that's not it. Oh, G. E? Hmm. Oh, no. We don't want trigger zones. That's only if you step on something. We want trailblaze system. So we have some sort of speed. We see how long it's been since the last tick. And internally, we update your position. This has nothing to do with updating the clients. Fascinating. Okay. Where is... Am I missing something? Because all new paths should get sent out to the clients. And maybe we could use another system for that. That's possible. Just iterate over the new paths, send them out to the rooms that they're in. All right. Let's see if we can find some other element here. I am truly surprised that those elements do not get notified out. Probably have some sort of fix me somewhere from my past self who was feeling a bit, I don't know. And what I'm actually thinking is that we could get rid of this destination system, because all we're doing here, look in the destination system, is really just calculating how long this is going to take and so on. But you know what, if we put it in line, we can't shuffle it off to something else later. We could have some sort of external system that just looks at all of the things that are currently in queued and churns through all of the pathfinding. Pathfinding is super expensive. Very, very CPU intense. Yeah, I'm guessing we just create a new system that sends these out. So how is that different than just sending it out right here? Doesn't seem like it is. Do we have a resource for sending this out? Let's see. We have world. World is the ECS world. What else do we register? These are the components that we register. Trigger zone action. Is that a component? It is a component. I think we should also register. Oh, wait a sec. All right, hold on. Memory coming in. New paths. Look at that. There's new paths. Something used to actually get these out of here. It actually drains them. I see. So we keep collecting these new paths. So the destination to new paths based on the current path. And what does Trailblaze do then? Is it actually using new paths? No, it's using path. Okay, let's go back one. And destination system, it is producing what? And we say this is a component, a new path. Ah, okay. It actually is doing both. It's writing to both path and new path. Huh. Okay, fine. And the second one is so that the game master can actually pull the paths out and broadcast them. Got it. All right, past self, you win this one. Who's calling this? No references found. A function definition. This tick doesn't call itself. Let's go back and look at Game Master. Go to tick, start tick. Yeah, we do some setup, etc., etc. Here we're tracing the tick. It looks like we do the tick and then we process some LinkedIn stuff. However, we are not sending out all the outgoing paths, which we should do after every tick, probably. ECS dot. That's probably also a write lock. Await. In this case, we want to get the. Oh, what is it? New paths? Yeah, new paths. Interesting that this is not mutable. Now we're taking a write storage and draining it. Why is that not mutable? Okay. Hmm. I wonder if we're gonna have to do that for everything, right? Broadcast paths, broadcast, the damage, the yada yada, whatever the actions are. It does mean that the ECS doesn't need to know what the outgoing pipeline looks like for these things. So I get that. It's nice. It does mean we have this kind of buffered storage. One of the other differences here is that everybody gets all the paths at the same time, or nearly the same time. But who do I send this out to? What is included in a new path? Entity ID, zone, and positions. So I'm still gonna have to send that out to everybody. I'm not sure I buy this one. Past self, I think our opinions are changing. Well, I don't know. I mean, in one case, we could just give the outgoing MPSC queue to ECS. It used to be a lot different, right? To send out to one entry was very, very cumbersome. But now you just say, this goes to this person, go. It's much more simple with the new connection system. No, I got a hair on my glasses. Hold on a sec. There we go. Yeah, maybe we should just get rid of this. I'm going to override past self and absolutely get rid of this. We instead are going to give a resource the game state stuff. I'm not going to process this here. New path, goodbye. Okay. Goodbye, new paths. You're gone. Release this. Move on. Good morning. I don't know what you mean by releasing. The whole game? I would like to have the game in a playable state. We'll get there. What do we have in here in terms of last tick, as entity, add trigger zones? That's right, we do add trigger zones late. Yeah, unfortunately, the game isn't quite playable. Well, I think that thing should be a resource. Probably new this instead of default this. Who's creating a defaulted ECS? We just import ECS and say this is new. That'll show up as a compiler error. Is nobody controlling one of these? Yeah, we don't need that. Do not need new paths anymore. Yep. New path goes away. Fix me, send to zone. There we go. What else? Oh, we have dead code. Public function new. Nobody owns an ECS. I am having trouble believing that. Game Master should have an ECS. So game state, yeah, it just says ECS. master should have an ECS. There it is. It's in one of those. Oh, that's strange. Okay. The errors are not across the workspace, they're across crates. So I need to set up cargo watch here. All right, this will be ECS new, and we are going to give it clone of the outgoing packets. Good. Go adjust that. What is the signature of that outgoing packets? Oh goodness. Did that? That means that Tokyo's not in here. Here's Tokyo, sync MPSC. And outgoing packet. That's outgoing packet is from stream multiplexer. Yes. And packet's from what, message? All right, now this is all sorts of broken because those don't exist here. Game state, cargo, game state lib 17. Actually, what is stream multiplexer on in the other ones? Stream multiplexer 081. There we go. And messages. You know what, let's just... Yeah, that should be enough there. Now that we have that, we can insert this as a component. I need actually a component or something to wrap that, don't I? And what is entity IDs here? Is that like proper entity IDs? No, it's just a struct. Okay. Does it need to be public? Why would that need to be public? Maybe pub crate. Okay, let's fix that. Do one of those. Create a new one of these with outgoing packets in it. Okay, now that'll be available to all of the systems and they can send that out right away. And those packets out as they need. So now if we go back into system destination, All right, we got 15 minutes, maybe 14 or 13. Now that we have a new destination, we actually need to send that to the room. How do we send that to the zone? Because this is a destination system. Yeah, this, I don't have access to those other elements. There is a really nice sort of function in this file is broadcast, or what was in here? Game state zone. It was like broadcast to zone or something like that. Oh, that was in data. Oh, and this doesn't have data. Ooh, like, oh, wow. Okay. This doesn't know where they are. I mean, it kind of knows who's in the same zone because there's probably a location blurb in here about that. Oh, I see why it's the other way now. Huh. Fancy. Okay. I thought this was going so well until that moment. Location basically has its own info in it, right? All right, we're going to undo. All right, putting new paths back. Fine. Destinations to paths. I think that's actually correct. Let's go back into component. Put that back. Now if we go back into system destination, do these elements here. Okay. It's fine. If we go back to game master, we can use default again there. That's fine. Okay. That should actually work. Problem though is that we still have to do this in the tick. So here we have a start tick. Now for each one of those elements, key here is that, let's go back. It's right there. We have data. We've got a reference to this. In the start tick, data, it's right there. Where are we using data in here? Yeah, remove player zone and connection. Okay. ECS dot read dot await dot new paths. Okay, those are new paths. And now for each one of those, we actually broadcast it to the zone that it needs to go to. Now, I know a while back I spent a lot of effort actually pulling the data stuff out of there. Is that because it was kind of circular? Sure. All right, anyhow. think this is fine. This is probably a little bit more clear. And that produces new paths. New paths get consumed and pushed out to the different rooms. Or new path, new paths. Do this. Data dot so what do we want to call on data? Send to zone. That's what we want to call zone ID in the packet. Okay. Send to zone. The zone ID is going to be new packet. I think it's just zone ID there. Now we have to construct a path. Send out. Well, let's call it packet. Oh my goodness. What's going on with my network? Hold on, we're dropping packets. All right, let me. It seems to have stabilized. Who knows? All right, so we'll send that to the zone. That also doesn't result. I don't think I want to do much for that result other than just log it, maybe. Does it already log it? It does. Oh, you know what would be neat here? If we could do kind of collect these into just a few packets. Basically, sort these into the zones that they need to go into. And because sent to zone can take n number of packets, and it'd just be one call. Well, that's not too bad. Let's see, what could we use here? A little hash map, zone ID to packet, to array of packet, or what else? All right, let's create our hash map. Interesting, okay. I don't think I can collect into a vector of... No, okay. But, zone to packet equals this. Now we probably need to convert these, don't we? There's a new path. We go look at that type, set a marker here. A new path basically has the entity ID, the zone, and positions. And technically, we do not. We do need the entity ID along with the positions, because that'll make up a packet. that plus positions as a packet, and the zone is just kind of the destination. So let's first iterate through these. I guess we could do it all at once. Iterate, collect. We'll do a fold on this. Okay. Actually, I gotta get going. Oh, guys. Okay, let's see how far we can get. Zone to packet. This is going to be it's a hash map of zone ID, which I think is just type ID. That's going to be to a vector of packet. Okay. Just default that. Ta-da! It's there. All right, now. Oh, I don't have that in here. Use standard collections hash map. I like this. Okay, this is neat. Yeah, well, we could fold over that. It's pretty much just this. All right, so in this case, we'll say we have a new path that needs to become a packet. So let packet equals. So how do we create a new path? So we need a path. Let path equals path no. I'm guessing that path doesn't even have that. No, that's the wrong kind of path. We want this one. Positions is just a vector of points. What's the other one? What is type vector path? Oh, it's just a vector of points. You're the only one that uses that too, huh? Technically, we don't use the stream ID thing anymore. Interesting. All right, I'm gonna have to think about this one. This one's a little interesting because we have game types path. And we look at the paths. We have new path. So in game state, we have basically two different kinds of paths. And this one looks exactly like the other one. Just a vector of points. Well, it might be the same kind of points. And then this one here that we send out. Yeah, this one's gonna have to change because the subject, the entity ID is wrong. All right, well, I think that's probably a good stopping point. Very cool. Thank you all for hanging out with me. We're gonna get rating here. Let's say Zeratar again. I'll raid Zeratar. Start the raid. So, well, y'all, until next time. Bye-bye.